Hey guys, Miss Davis here. This is the 10.4 video geometric series. So pause the video, write down the essential question. How do we solve problems with geometric series? Okay, so geometric series is going to be a formula that you're going to use. So you're going to, anytime you hear well, it won't actually say geometric series in the problem, but anytime they ask for the sum of earnings, so sum means total. So anytime they're asking you for the sum or things, the values added over time or the total earnings, that's going to be a keyword here, total, is going to tell you that you need to use this formula here, the geometric series. So this S of n here represents the sum, and then our A of n, or sorry, A sub 1 is going to be our initial term. Our A, and there it is again, A sub 1 again, so minus A sub 1 again. R to the n, now this is very important right here. In other problems, the R value was just the percent, but in these kind of problems, the R value is 1 plus or minus the rate as a percent. Okay, so, and it's going to be the percent as a decimal. Okay, so if it's increasing by 4%, it'll be R will be equal to 1.04. Okay, now good thing is this formula is going to be given to you on the reference sheet. So you do not have to memorize it. Again, it's on the reference sheet, so don't worry too much about memorizing it. You just have to know how to plug it in and when to use it. So note that a series, so we're talking about a series, is just the sum of a sequence. Okay, so it's going to be everything added together, every year's earnings and total added up together. So we have to know when exactly to use it. So let's read through number 1, because sometimes we don't have to. We can just use what we've learned already in Unit 8. So Alexa earned $33,000 in her first year of teaching and earns 4% increase. So we know that that's going to be 0.04, and we're going to have 1 plus because we're earning in each successive year. So write an equation to model the amount of money she will be making each year. It doesn't say total, okay? So we're going to be using just the regular equation that we've used before. So A sub t, not sub, sorry, A of t is equal to that 33,000 parentheses 1.04 to the t. So each year is going to be represented by t. Okay, so if it's each year, you're just using the regular compounding formula that we learned about in, again, Unit 8. So then part B says, using your equation, determine how much money she will make in her 15th year. It doesn't say how much total she's made over the 15 years. It says how much will she make in her 15th year. So that means we're going to use this equation and sub in a 15 for T. Okay, so we're going to find A of 15 equals 33,000, plug and chug, 1.04 to the 15th power. Okay, so when we plug that in, we get A of 15. Again, type that right into your calculator, and you're going to get 431, I'm sorry. So let's go back a little bit there. 431.1356. And if we're dealing with money, we always want to round to the nearest cent unless it says nearest dollar. Okay, so we always want to round to the nearest cent, which is the hundredths place, unless it says to the nearest dollar or something else. Nearest $100, nearest $1,000. Okay, if it doesn't specify, or it does actually, nearest cent. So we got 59,431 and 14 cents. Okay? All right. So again, after plugging in 15 into our just regular compounding formula, this is how much she will make in her 15th year. Not how much she's made all together added from year 0 all the way up through year 15. This is just in her 15th year she would make this money. Part C says write a geometric series, which again, it's not going to usually say this part, for her total earnings over n years. So they're asking you for total earnings, which means, I'm going to just draw an arrow over here, all years income added together, or added up. Okay, so that total earnings over n years. Okay, so again, they want to use n. I use t in this problem, so let's just switch it over to an n. So we're going to use the geometric series formula, S of n, which is the one up here. Okay, so I'm going to zoom out. And our formula would become, again, we're just plugging and chugging, S sub n equals our a sub 1, this right here is our initial term. So her initial amount of money that she made in that first year was $33,000 minus our a sub 1 times r to the n. So it's going to be 33,000 again. Now in this case, our r value is going to be the rate that we already determined with the 1 plus included. Okay, so it's not just the 0.04, it's going to be the 1.04. That's different than in previous problems. To the n power, all divided by our denominator is going to be 1 minus the 1.04. Okay, so again, our rate is 1.04, not just the 0.04. So that's the geometric series formula, okay, with these numbers plugged in. Now, using this formula, it says to find Alexa's total earnings for her first 15 years of teaching to the nearest cent. So once again, we're going to be plugging in 15, so n is going to equal 15. We're going to plug it into that formula, and it's going to tell you all of her year's incomes added up together over the 15 years, okay? So for this, we're going to do S sub 15, so plug in a 15, and just copy down what we had before, so 33,000 minus 33,000 times 1.04 to the 15th power, all over 1 minus 1.04. Okay, so at this point, you would type this whole thing right into your calculator. So this whole thing, you would type into your calculator as a fraction. And when you do that and hit enter, you end up with S sub 15 equals 660, 778.3920. Okay, so again, it should be a really large number because if we're taking her initial amount of money she made in year 1, which is that 33,000, and adding it up every year for 15 years, then it should be, and it's growing each year too, because it's compounding, or it's growing at that 4% rate increase, then it should be a much larger number than what we started with, because it's 15 years worth of salary. Okay, so again, we need to round to the nearest cent, so we're going to round to the 9 here. So S sub 15 equals, so it should become 660, so $660,778.39. So again, let's just kind of rephrase this. This is all 15 years salary added up. Okay, hope you can see that. Let's just say added up. All right, so let's go ahead and flip on over to the next page. Okay, so here's an example where it doesn't say specifically use a geometric series. So let's read through and let's help delineate between when to use just the regular compound formula and when to use the series. Okay, so example 2, a new website got 4,000 page reviews on the first day. So that's going to be our initial term, or that's at the beginning, right? During the next 4 days, the number of page views increase by 30% each day. So if it's increasing by 30% each day, it's going to be 1 plus 30% as a decimal is 0.3 or 0.30. So per day, what's the total amount of page views in the first 5 days? And it also says round your answer to the nearest integer, so that would be the nearest whole number. Okay, so what is the total amount? This right here needs to be ringing bells off in our head, that this means that we need the series or the sum of all the first 5 days. So day 1 plus day 2 plus day 3 plus day 4 plus day 5. So we're going to be using this geometric series formula, again, located on your reference sheet on your Regents exam. If it said how many views were there on the 5th day, then you would just use the regular one without the fraction. So just the one that we learned before. Okay, but since it says total amount, we gotta make sure we're using the sum formula. So here we go. Let's go ahead and plug in what we know, and we've got S of n, our original formula that we're gonna write. Let's just plug and chug. So our A sub n is going to be our first term, which is that 4,000 views on the first day, minus our 4,000 again, times, now our R value is going to be this added together. So it's 1.30, or just 1.3. All right, to the n power, all divided by the 1 minus R, so 1 minus 1.30. So this is your general formula with n plugged in. So now we need to find on the first 5 days, that means that n is going to equal 5. So now we're going to find the fifth term in the sequence, or total amount of views after 5 days. Okay, so plug this in, 1.30 to the 5th power, all over 1 minus 1.3. Okay, again, you're going to type this whole thing into your calculator, and when you do, you get S sub 5 equals 36172.4. And if we want to round it to the nearest integer like it says, we're going to round to the nearest whole number of views. So 36,170, this 4 means we keep it a 2, and this is the total number of views in the 5 days, not on the 5th day. Okay, so it's how many total views counted up from day 1, day 2, day 3, day 4, day 5. All right, example 3. A fisherman harvested 350 kilograms of fish on Monday. From Monday to Sunday, the amount of fish he harvested increased by 10% per day. So again, we know here we're going to have 1 plus 0.10. What's the total amount? Ding, 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 ding. Total amount means you need the sum, or that S sub n. What's the total amount of fishes that the fisherman harvested in the first 6 days, which means that n is going to equal 6. Round your answer to the nearest whole kilogram. All right, so let's use the series formula. If we just started with the general one, again, it's S sub n equals. Here's our initial amount, so A sub 1 is going to be the 350 minus, again, the 350 times the 1.110 when we combine them together to the n power, all over 1 minus 1.110. 1.10. Okay, so there's a general formula. Now let's plug in our n equals 6. So S sub 6 is equal to 350, and we're just plugging in that 6 again. Okay, so plug it in to your calculator. Whoa. And get, that should be a 6 down here, 2700.4635. All right, so the nearest whole kilogram, we need to round this, and we're going to round, let's see, so 2700 is going to be kept the same because the 4 is less than 5, so we get 2,700 kilograms were harvested in total over 6 days. Okay, so just make sure you know that that's the total, not on the 6th day. Okay, all right, so beautiful. Go ahead, write your summary, do your practice. You got this.